Hey guys, welcome to Module 5B, Determining Equations of Lines. Today we're going to, you guessed it, determine the equations of some lines. And so there's a couple of different ways that you're going to do this. The first is if you're given a graph, you're going to identify the y-intercept, b, and you're going to determine the slope, m, but you're going to do that using like a right triangle between two perfect points. And when I say perfect points, what I mean is points that have whole number or integer coordinates. And so they cross, it's a place where the line crosses the grid at a perfect corner of a grid square. And then when you're done, you'll have your m and your b, and you write your equation in slope-intercept form, y equals mx plus b. The other way that you're going to be asked to do this is given 2 points. So they'll say, hey, here's 2 points, or here's a function, input and output, and there's 2 of them. And you're going to find the equation of that line. So the first way that you do that, the first thing you're going to do is find the slope. And you find the slope using the slope formula, m equals y2 minus y1 over x2 minus x1. It's our common change in y over change in x formula. Then you use the point slope formula, which is basically just the slope formula using one point, x1, y1, and then a generic point, xy, to get your actual point slope form of a line. So I take my y minus y1 over x minus x1. And so notice here, I don't have a subscript of 2 on the first x and y that are written here. That's because I'm going to leave them as x and y. I'm not going to substitute a point value. But when I see the subscript of 1, that means that that does represent an actual point that you'll be given, right? So if I multiply both sides of this equation by the denominator, x minus x1, what I get is the point slope form of a line, which is y minus y1 equals the slope times x minus x1. Once you have that equation written using an x and a y, and then the x and y from one point, as well as the slope that you've solved for, then you are going to just do some quick calculations in order to convert that equation to slope-intercept form. Or less often you might convert it to standard form, but typically you won't leave it in point slope form. It'll be, you'll have to simplify it a little bit. So here's some examples, and I'm going to use each of the methods that we talked about. In this example, we're going to find the equation of a line given this graph. So if you recall the steps that I talked about first, the first thing is to note the y-intercept. So I come over here to where the line crosses the y-axis, and I'm going to label that point over 0 up 7. Now I need 2 points in order to find the slope. So I'm going to find another point where this line crosses a grid line at a perfect intersection. Here is one such point. Here's another one, right? I'm just looking at perfect points here. So any of these points would work. I'm going to go ahead and use this point here, the one that's in quadrant 1, so over 3 up 9. I kind of chose it arbitrarily, but it's nice because I'll wind up with, I'm more likely to wind up with positive coordinates when I do it that way. So I just chose that one. All right, so I am going to draw the slope triangle connecting these 2 points. That's my little right triangle. I calculate change in y, which is up positive 2. And my change in x is an increase of 1, 2, 3. And that's positive. So my slope is change in y over change in x equals 2/3. And my b, my y-intercept, is 7. So I can use that in my slope-intercept form to write the equation y equals mx plus b, which becomes y equals 2/3 times x plus 7. It's that easy. That's our slope-intercept form of the line. All right, it gets a little more challenging when you're not given a graph. So the first thing we're going to do is find the equation of the line passing through the point 2, 7 with an undefined slope. Now, I did technically talk about how to find this. This is a point and a slope, right? But we need to know that, so I can use my point slope method, okay? Like the point would be 2, 7, and the slope is just going to be the change in y over 0. That means it's undefined. However, we don't have to go through the whole process because when I know that my slope is undefined, it means that I have no run. If that's the case, if I have no horizontal change, then that means I'm dealing with a vertical line. And if I'm dealing with a vertical line and it has to pass through the point 2, 7, then it must be a line that passes through, excuse me, that's not what I want to do, that passes through x equals 2. So this is just the line x equals 2. So I know it's a vertical line because it has no horizontal change, all right? And I'm only going up and down. And you have to remember that even though it's a vertical line, it's a line with the x in it because it's passing through the point x equals 2. So the equation of the line is x equals 2. So this one's actually easy. X equals 2 is the equation of the line passing through the point 2, 7 with an undefined slope. If you were given a question like this and it said that the slope was 0, that would be a horizontal line. And that's because it has all horizontal change and no vertical change. And then we get a line y equals. So I would be looking at the y coordinate of that point instead of the x coordinate to figure out where it is. Okay. And I should go ahead and label this as 2, 7 on that point in case you were trying to plot the point and see whether it's a horizontal or vertical line. That'll come up in your exercises. Don't worry about it. Contact me if you have trouble. I am here to help. Now, this is the more standard form that you're going to be given for these exercises. So we're given that we have a function p of x, and we know that when the input is 6, the output is -11. That means this is the point 6, -11. Here, hold on. I don't like the way this is drawing. Let me change my pen real fast. Just bear with me. And we're going to say that this is the point 6, -11. And when my input is -3 into my function p, my output is 4. This tells me that the point -3, 4 is also on the line from this relationship. So I'm going to go through the steps that we talked about for a point slope form. That means that my first step is to find the slope. And I find the slope, I find my slope using the slope formula. So that's m equals y2 minus y1 over x2 minus x1. And I can call either of these x1 and y1 and x2 and y2, but I'm just going to go ahead and label them from left to right. So I have x1, y1, and x2, y2. I like to label them so I can make sure that I get my points substituted in the right order. So y2 minus y1 is -11 minus 4. And x2 minus x1 is 6 minus -3. So this gives me the ratio 11 minus 4 is -15 over 6 minus -3 is the same as 6 plus 3, which is 9. And if I simplify this to get a simplified fraction, then I wind up getting 9 goes into 15 once with 6 left over. Nope, that's not what I want. I don't want a mixed number of 1 and 6/9. I'm going to divide top and bottom by 3. That's a common factor, and that gives me -5/3. And that is my slope. Now I'm going to find the equation of the line using point slope formula. And that formula is y minus y1 equals the slope times x minus x1. And in this case, I'm going to keep my same x1 and y1 from when I found the slope, and I'm going to leave my first x and y as they are. So the x's and y's that have no subscript are going to stay in our formula. But I'm going to substitute the value of the point here when it says y minus y1. So y1 in our point was 4. So y minus 4 is equal to x minus x1. x1 was -3. And that is times the slope, which is -5/3. So this is technically the point slope formula, but when you want to, when you are writing your answer, you're going to want to write it in slope intercept form. And to do that, all we're going to do is simplify it and solve for y. So the first thing I'm going to do is distribute my -5/3 because in my slope intercept form, I don't have any parentheses. So I distribute by multiplying -5/3 through to both terms. So I have y minus 4 equals -5/3 times x. And then remember, minus -3 is the same as plus 3. So this is plus -5/3 times 3. It was a positive again because minus -3 is a positive 3. So I'm going to simplify this. I get y minus 4 equals -5/3 x, and divide by 3 and then times 3 is a 1. So this is just -5. I'm not done yet because I still have -4 on the same side of the equal sign as my y, and I want to isolate my y, so I'm going to add 4 to both sides and combine like terms when I do to get y equals -5/3 x minus 1. And that is my final equation. And that is the slope-intercept form of the line with function input 6 and output -11, and function input -3 and output 4. It's the same as finding the equation of the line passing through -3, 4, and 6, -11. Now, I'm going to sneeze, I'm sorry. I think it's disappearing. I don't know. Excuse me. Okay. So now we'll talk about parallel lines with no sneezes. This symbol here means parallel lines, okay? So parallel lines never intersect. That's because they have equal rates of change. So they're equally tilty on a graph, so they never cross. That means that the slopes of parallel lines are equal. All right, so say that we have line 1, and the equation of line 1 is y1 equals change in y over change in x times x1 plus b1. My subscript of 1 here just means it's all on the first line. All right, so these are all the parameters that apply to the first line. Then if I have line 2 and y2, I'm going to write this down. If line 2 is parallel to line 1, I'm going to write that better. I'm going to write it in black. It should stay on here. I'm going to say line 1 is parallel to line 2. That's how I use this notation, these two little lines. Then in that case, I get this relationship that my second line, y2, is equal to the exact same slope from the previous line, change over y over change over x. These two are equal, times a different x and a different b2. So notice that they have different y-intercepts, but they have the same slope. If they have the same y-intercept, then we would say those lines were not parallel, they're coincidental, which means that one line is directly on top of the other line and they're equal. Okay. On the other hand, we could have perpendicular lines. Perpendicular lines, signified with this upside down T symbol here, means that the lines intersect at right angles. The slopes of parallel lines are negative reciprocals. That means that they're opposite both in sign and in orientation. So if it was a whole number, it'll be the reciprocal of that whole number. If it was a fraction, you'll flip the fraction. And in both cases, you'll also change the sign to make it either positive or negative, depending on what it started as. So if I started with the equation of line 1, like I did above, y1 equals change in y over change in x times x1 plus b1, then for my perpendicular line, I'll have a different y and x. The slope will be the opposite sign and it will be the reciprocal. So notice that now I have change in x over change in y. Now that is just the reciprocal, the negative reciprocal of the original slope. Different slope or different y-intercept, different x and y. Okay. So we're going to do some examples. We're going to consider the line 2x minus 11y equals 4. And we're going to use the definition of parallel and perpendicular lines to first give the equation of the line that's parallel to that line passing through a specific point. And then we're going to give the equation of the line that's perpendicular to that line also passing through the same point. So the first step here is to find the slope, because I can't, if I'm going to write a parallel line, it's going to have an equal slope to the line that's given, but I need to know what that equal slope is before I can find it, or before I can write it. So the first step is going to be to find the slope of 2x minus 11y equals 4. And I do that by writing it in slope-intercept form. So I'm just going to solve for y here. I'm going to solve for y by first undoing any addition or subtraction that's happening on the same side of the equal sign. So I'm going to subtract 2x from both sides of the equal sign here, giving me negative 11y. It's very important that you keep the minus sign there, equals negative 2x plus 4. I could write this as 4 minus 2x. That would be completely acceptable. But if I'm going to be looking for my slope in y equals mx plus b form, I like to have my mx term come first. Okay, so just keep the sign with it though. So it's a negative 2x. Last, I'm going to isolate for y by dividing every term by negative 11. I do this. This is the same as distributing my division of negative 11 to both terms on the right side of the equal sign. So what I'm left with is y equals positive 2/11 times x plus 4, or no, minus 4/11, because that winds up being negative 4. So my slope is the coefficient of x, 2/11. Right. I had some questions on this topic before from the 5A exercises, where somebody wrote to me because they were getting a syntax error when they were entering the slope, and they were entering this entire term, so like 2/11 x as the slope, but the slope is only the number part. Okay, and I'm only saying that here because it's a very common misunderstanding. And even though only one person wrote to me about it this time, I've had that question multiple times every time that I teach college algebra or any form of algebra. All right, so I'm gonna add a little space here. That didn't give me quite enough room to solve this. Our next step, once we have the slope, is to use the point slope form, because now we have a slope and we have a point, to find the equation of the line. So we're going to use point slope form. Y minus y1 equals the slope times x minus x1 with the point 2, 4. Right? So I'm going to write down my formula. Y minus y1 equals the slope times x minus x1. And now I'm going to substitute in my slope, which, by the way, m is 2/11 from above. So I'm going to write that as y minus y1, which this is x1 and y1. So y1 is 4, equals the slope 2/11 times x minus x1, which is 2. And now I'm going to simplify to put it into slope-intercept form. That's our y equals mx plus b. So to do that, I'm going to isolate for y. The first thing I'm going to do is distribute my 2/11 to both terms on the right-hand side, giving me y minus 4 is equal to 2/11 times x minus 2 times 2/11. That results in the equation. Actually, you know what? Let me get some more space. Why did I get it so squeezy? So that gives us the form y minus 4 equals 2/11 x minus 4/11. And now I'm going to finish this equation by adding 4 to both sides so I can isolate for y. But when I add that 4, I'm going to write it with a denominator of 11. So I'm going to automatically convert it on the right-hand side to be 44/11. It's still the same as adding 4. I'm just writing it in a form that I can incorporate with my given constant. So I have y plus 0 equals, so it's y equals 2/11 x minus, well, negative 44/11 plus, or negative 4/11 plus 44/11 gives us minus 40, or gives us plus 40/11. And that is our equation of the line that is parallel to the given line of 2x minus 11y equals 4, passing through the point 2, 4. It's parallel because it has the same slope. But notice that the y-intercept is different. All right. Now we're going to give the equation of the line that's perpendicular to that line passing through the same point 2, 4. That's okay. It can be perpendicular and pass through the same point. However, it is going to be it's a similar calculation, but we're going to use a different slope. In this case, the first thing we're going to do is find the slope. But I'm going to use the fact that I know the parallel slope or the original slope. And that means it's going to be the negative reciprocal of 2/11. So that means I'm going to go from a positive to a negative, and I'm going to change the orientation of my fraction to be negative 11/2. So this is going to be the m for my equation. Then I'm going to use my point slope form. To give me y minus y1 equals the slope times x minus x1. And in this case, my x1 is 2 and my y1 is 4. That's the same as it was for the previous problem because it's the same point, but the equation will be different because I have a different slope. So this gives me y minus 4 is equal to negative 11/2 times x minus 2. So now I'm going to distribute this the same way I did before. My negative 11/2 is going to get distributed to both terms on the right side of the equal sign inside of the parentheses. So I get y minus 4 is equal to negative 11/2 x minus 2 times negative 11/2. When I simplify this, I have a negative and a negative, which is going to give me a positive. And then, I also have times 2 and divide by 2, which 2 divides 2 one time. So I just get positive 11. So on the left side, I get y minus 4 still. And on the right side, I have negative 11/2 x plus 11. So to my last step to get into the slope-intercept form, by the way, this I guess is our third step anyway. Is to add 4 to both sides. That'll let me isolate for y. And my final answer is y plus 0, or just y, is equal to negative 11/2 x plus 15. And so this is my final answer. My slope is the negative reciprocal. And my y-intercept is different from the parallel line and different from the original line. It could theoretically be the same as the parallel line. Just that would mean that the point that it was passing through was the y-intercept though. So, you know, we do what we can. That is our content for today. So if you have any questions, please reach out to me via email. I'm always happy to help, and I hope you have a great week.